All right, today I'm going to be working on excuse me, integration of powers of sine and cosine. And this is the page, these are the problems that are on the back of page 107 in your packet. It's sandwiched in between page 107 and 110. Okay. If we are looking at integrals involving sine and cosine, we want to see both of them, generally speaking, in the integral, because when we do our u/du substitution, we need the other function to be there. The derivative of sine is cosine, and the derivative of cosine is negative sine. So we want to make sure that we have those somewhere. So we may have to manipulate some of these problems in order to get that. If I am going to use, the first one's fairly simple, because what I'm going to use for my u is the more complicated one, which is the sine. So sine of x, so my du will then be the derivative of sine, which is cosine. And so now what we have is the integral of u cubed, and then everything that's left is my du. Okay, let's increase by 1 and divide by it, and don't forget your plus c. And then we substitute our u back in. So it'll be sine to the 4th power over 4 plus c. And that's it. Okay, for the next one, I do see sine and cosine, but they both have powers. And I don't want that, because when I choose a u, I'm going to choose a u that is just a single sine or cosine. And so I want a single sine or cosine as my derivative as well. So what I'm going to do here is I have an odd number of cosines. So I'm going to change this into cosine times cosine squared. I'm just breaking up the 3 of them into 1 and then 2 of them. And then sine to the 4th x dx. And the reason I'm doing that is I want to change this cosine squared into 1 minus sine squared, because I want everything except the cosine in terms of sine. So hopefully that will help me to find a better u, or find the best u for this problem. Cosine x, 1 minus sine squared x times sine to the 4th x dx. All right, what I'm going to do is I'm going to, because I'm going to use a u that has a sine in it, I'm going to move this cosine next to my dx and distribute the sine to the 4th through the parentheses. So sine to the 4th times 1 is sine to the 4th minus sine to the 6th, and that's times cosine x dx. All right, now I'm ready to choose my u. My u is going to be sine. So that means, that my du is going to be cosine x dx, which I have here. So we have the integral of u to the 4th minus u to the 6th du. That's a much simpler problem to take the integral of now. So on each of these, the parentheses really mean nothing now. So on each of these, I want to add 1 and divide by it. Add 1 and divide by it. Don't forget your plus c. And then substitute u equals sine x back in. So I have sine to the 5th x over 5 minus sine to the 7th x over 7 plus c. And that's it. Remember, you want to see both the sine and the cosine in the problem. So if you're missing one, then what you'll want to do is be sure to turn it, just like I did up here. Let's see, go up a little bit. Just like I did up here, changing one of them into, or a pair of them into 1 minus sine squared or 1 minus cosine squared. I hope this helps.